Hey, what's up, guys? This is Chung here, and so this time let's take a look at another interesting tree problem here. Number 337. It's called House Robber 3. Okay, so let's read the description here. So there's a thief here. The thief has found himself a new place for his thievery again. And basically he found like a tree structured house, right? And he can traverse from the root house all the way to any house, and each house has a value stands for the money inside the house. But but he cannot take all the house. He cannot rob all the house. So like it says here, it will automatically contact the police if two directly linked houses were broken into on the same night. And you need to calculate what's the maximum amount of money the thief can rob by traversing all the trees here, right? So what does that mean? It means you cannot basically rob two adjacent uh, tree node here or a house here. Like for example, if you rob three here, you cannot rob three and the child. You can only rob his grandchild here. Same thing here. Say rob here, you cannot rob this one or this one or this one. Yeah, it's very interesting question here. So it seems like it's hard to become a thief. It's hard to become a thief nowadays. You need to be you to be a good thief. You also need to be a good programmer. So that you can get rob the most out of those houses. Cool. Anyway, so it's still a tree problem here, right? So going from top down, how can you get basically the most node values, right? And this is like if you think carefully, this thing is it's gonna be clear to to sh to be under to be able to see it. This is gonna be a recursion, like more like a dynamic programming, because every time when you reach a new node, you will get you will try to get this new node max values from his child or grandchild nodes here, right? So how will this work? Because let's say, for example, here, I'm gonna write it bigger here, 3, 4, right? So when you reach a node here, right? Okay, so uh, when you reach a node here, you only have two options here. So you either rob this house or you don't, right? And basically we just need to get the bigger value among those two options here, right? So let's take a look how we calculate those two options here. So let's say if you decide to rob this three here, you rob three, and then you cannot rob its left or right child, right? You can only rob its grandchild, which is the left of one or left of or right of three, and the grandchild of five, which will be another node here, which does not exist in this case, and this one. Basically, if you don't rob three, if you rob three here, then you can rob all its grandchild, right? And another case, if you don't rob three, you can only rob its child, right? Yeah, basically that's the idea, right? We're going to use here. All right, so we're gonna like create a helper functions here, like the rob helper, right? So it's gonna be the node here, right? And here we're gonna have a result here, and then we're gonna call the rob helper with the current root, right? And then we'll return the result in the end, right? So like we discussed first, okay, yeah, we need to check if node is none, right? If node is none, right, we just return 0 because we got nothing to rob, right? Otherwise, right? Otherwise, let's say we decide to rob current node, right? Then that will be what? That will be the current node the current node will be the node dot value, right? And then we'll be getting the left side and the right side, right? So uh, left money, right money, right? Equals to 0, right? Let's define these two variables here. So and if not current node has a left value, right? Has a left node, then what we'll do? We'll do this, right? Money. So we basically will rob all the grandchild's nodes on the left side, right? That's how we define the left money. Gonna be a rob. So we'll be using the previous result here, right? And another side, right? Because we want to rob both sides. We don't want to miss any possible house, right? Of the left side grandchild node. Same thing for the right side. If there's a right side subnode here, we do what? We do a right. We assign this right money, right? With this rob helper, right? Rob helper node dot right side, right? And then same thing for two uh, subnodes of the right side subnode, right? That's how we rob all the grandchild's node, right? And then in the end, we need to what? We need to return, right? We need to return a maximum of. So okay, so that's the okay. Let me um equals to what? Equals to uh we will rob the current, right? Plus, right? Left money, right? Plus the right money, right? That's rob current, right? How about the not rob current? If we don't, if we're not robbing the, if we're not robbing the current, so what's gonna be the value? It's gonna be the helper, right? Left, right? So if we don't rob the current, we can rob its the current left and the right node, right? And then in the end, we just return the max of current and the not rob current, right? Yeah, so basically that's how we define. So the key point of here is rob helper here. It's like the it's like dynamic programming. It's like, but this instead this one will be like top down, right? It's not bottom up. So we don't use a array here. Instead of we're using a recursion function. But same thing here for this recursion function rob helper here. What it returns is for the current node, what is the maximum value? I'm sorry, what's the maximum money I can get for the current node, and then we just keep recursing over and over until we reach all the way to the end. Then we just use the pre-calculated result. We come back here and then we just form for the root node here, right? But okay, so since you guys know this recursion function here, okay, one thing, if you run this one, I think this will uh, Rob. It's not Rob, it's Rob. Okay. Uh, yeah, we don't need the result here actually. We can just return here. Yeah, we can just return this one here. Return this. We don't need another result variable here. Just return. So the logic is correct, but if you submit this one, you will get like time exceeds execution limit because remember with all with the dynamic programming, we want to reuse the previous calculated result, but here we're not, right? We just keep doing the recursions over and over. Because why? Because let's say if you're doing recursion for the node left, right, it will include this one, node dot left left. We're doing all the recursions for everyone, right? So an easy way to fix this is going to be we're going to have like a money dictionary. We're going to have a dictionary, whatever the dictionary would be, Rob dictionary, right? Rob dictionary. So this Rob dictionary will save the maximum money we can rob for each node, right? So in that case, so every time before returning this result, we just add the current node. We just add the current node, the result for the current node to the dictionary, right? This is going to be a node. It's going to be the uh, yeah. I'll just copy and paste here. Yeah. So for each node before returning it, we just record the maximum money the thief can rob from this for this current node. And then at the beginning here, right? So we can use that. We can check if the node is in, right? Is in the rob dictionary, right? And then we just we simply return it. We return the rob the maximum value, the maximum money we get from that dictionary, right? That will save us a lot of time here, basically. Yeah, yeah, pretty straightforward. I think I'm gonna stop here. I think there are like more. I think there's another way of doing it. Instead of doing the recursions, there it's gonna be like a different one where you just decouple, because here we're merging, basically we're merging these two values, and we're only returning one values for this rob helper function, right? I think there's another way of doing it, is the instead of returning one variable, we just return both of these two. Yeah, basically we bubble up these two values all the way. We don't merge them. So in that case, we can use these two values to save some of the recursion costs here. But I think it's a similar idea here. Since we already have this dictionary here, I'm gonna stop here to only use the recursions with the memorizations for this dictionary. And yeah, okay, so basically for each node we get the maximum values if we rob the current, right? Current, that's that, and not rob the current. Cool, guys. I think that's pretty much it is for this problem. Yeah, thank you for watching the video. Thank you so much, guys. Yeah, see ya. Bye.